Morning. Welcome back. So, last class we completed with stacks and we started with queues. Queues is a data structure which is a linear data structure wherein the insertion and deletion happens in two ends. It is similar to a normal queue wherein the person who enters the queue would be the first person to go out of the queue. So the deletion happens from the front of the queue wherein the insertion happens to the from the rear of the queue. Like you would have seen, the person who comes first would be standing there and the next person who comes would stand behind that person. You won't be standing in front of him. The same way the insertion happens from the rear and the deletion happens from the front. Okay, and then you can implement queues in two ways. One is array based implementation, which is static implementation. That is, the memory would be allocated during the compilation time before execution. You cannot resize it, that is, you cannot increase or decrease the size of it. Whereas a linked list or the pointer based or dynamic implementation is nothing but during runtime you can adjust the size of the queue, that is, it can increase or decrease, that is, it can shrink or expand. And generally, queues are dynamic in nature. Yes, it can increase at some time, it can decrease, increase, keeps on changing. If you have more numbers, it is always better to implement it dynamically using linked lists. Fine. And then the operations of the queue are NQ is nothing but queue insert operation. The same way you had push in stack. The difference between the queue and stack is the insertion and deletion happens from one end, that is the top end in stack. So it is LIFO, like it follows the LIFO principle, that is the last element in would be the first element to go out, whereas queues, the insertion happens from the rear and deletion happens from the front. That is, there are two ends. One is for insertion and one is for deletion. So it follows the first in, first out principle. Fine. And we will be using array based implementation of queues, and we will be doing NQ or insertion into a queue, DQ or deletion of an element from the queue, and then we can write an algorithm as well as the program. The different variations or types of queues are single queue, double-ended queue, priority queues and circular queues. This would be a 3 marker. They ask you normally the operations performed on a queue or the types of queues, and then queue insert, queue delete, that is push or pop. One of them is definitely asked. Again, this also we will be having it in the lab. So today's class will start with excuse me. Today's class will start with the insertion of an element. Fine. How do we insert an element into a queue? That is performing the NQ operation. So suppose I have a queue. Since it's an array based implementation, I have, you can see the blank spaces. It's an empty queue, and queue of 0, queue of 1, queue of 2, queue of 3 and queue of 4, which means that queue is an array which has n elements. Since I here, what is the value of n? N is, the value of n is what? The value of n is 5 because I have 4 elements, 0 to 4, 0 to 4, right? And then Q be a queue of elements. Yes, the capital Q is a queue of elements. Here Q and Q are different. Q is a data structure, Q is a name of the queue. And then front and rear are the pointers. Yes, you need to keep track of the element which was for insertion as well as the element to be deleted. Yes, in stacks we had top. Since the insertion deletion happened from only one end, you did not need two pointers. The top only was there for both insertion and deletion, that is push and pop operations. Since in queues it happens in from both the ends, you would need two pointers, one to keep track of the element which has to be deleted, that will be taken care by the pointer front, and the element which has to be inserted, that is taken care by the pointer rear. So which key points to the front and the rear of the queue. And for insertion, the procedure is check the queue, check for queue full or overflow condition. Yes, whenever I am doing any insert operation, I need to first check whether there is any place in the queue or not. If there is no place, I will not be able to insert any element. So there should be place to insert, and then check whether this is the first element to be inserted. How do I check for overflow? If rear is equal to n minus 1. What is n minus 1 here? N is 5. So rear is pointing here, for example. Then definitely I don't have any place in my queue, right? Because already it is full. So I cannot insert one more element. So if rear is equal to n minus 1, queue full or overflow. Now check whether this is the first element to be inserted or not. Why do I need to do it? Because if this is the first element, then I need to make front also point to that element, that is the first element of the queue, right? Because if there is only one element of the queue, then both rear and front would be pointing to that, because rear is pointing because that was the element which is added, and front is pointing because that was, if since there is only one element, then that would be the element to be deleted. If there are more than one elements also, rear will change to the new element, but front will be pointing to that element only, because this follows the first in, first out principle. Next, if it is the first element, you need to not only reset the value of rear, you have to reset the value of front also, because that also has to point to that element. Front would be minus 1 in an empty queue. Otherwise, if the queue is not empty, then front should have some value, anything apart from minus 1. Increment rear and insert in that location. So suppose if the queue is not full and it is not the first element, what do? I increment rear, and queue of rear would be the element. This is the procedure how to insert an element inside the queue. Hopefully you have understood this. Now, let me start with an example. I will be inserting. Before that, what is the value of n? N is equal to 5 in this example. Okay. So, n minus 1 is equal to 4. Correct? So, n minus 1 is equal to 4, because n is 5 here. In this example, n is 5, and similar to stacks, you need to declare the size. Okay, hash define size is equal to, not equal to, hash define size 10, 12, 15, whatever. You can declare the size of it. You are not taking it from the user because it is static. It should happen during compile time only, not during runtime. And number of elements also you are not taking, as and when you perform the NQ and DQ operation, the element would be inserted or deleted. So, for example, Q is the queue of n elements, and then n is equal to 5. So, n minus 1 is 4. In this example, I am talking about this example, 0 to 4 is nothing but 5. Okay. After that, let me say front and rear. Front is equal to minus 1, right? And rare is equal to minus 1 because empty Q. Empty. There are no elements in the Q. You can say that there are no elements in the Q. So front and rear are what? Front and rear are minus 1. It's not pointing. It needs to point to the element which gets after inserting only. So it is not. Okay. Any doubts here? Hopefully you don't have any doubts. If you have doubts, please write to me in the chat box. After that, let me do Q insert. Let me insert 67. I need to insert a element 67, or NQ I can write, or NQ 67. Q insert or NQ 67. So first thing what I have to do, check for overflow condition. Q full or overflow condition. So how do I check for Q full or overflow condition? That is, if, where does the insert happen from? It happens from the rear. So if rear is equal to n minus 1. Check if rear is equal to n minus 1, right? What is rear? Minus 1. And what is n minus 1? 4. I have established it there. Not equal. Fine. Next, if front is equal to minus 1. Why? Because is this the first element in the Q or not? That is, check for, let me say, check for first element or not. Check if first element or not. It's not for. Check if first element or not. How do I do? If front is minus 1, right? If front is minus 1, then it would have been an empty Q. So if you are inserting a new element, it would be the first element, right? So set front and rear is equal to 0. Okay. That is equal to 0 is equal to 0. Then Q of rear is equal to 67 because I wanted to insert it there. Okay. So let me say front and rear are pointing here only. Front, rear. Front and rear both are pointing to Q of 0 and 67 I have inserted here. What did I do there? See, increment rear and insert, not that. Now I want to insert Q of insert. Before that n is 5 for the example. According to the example, the value of n is 5, n minus 1 would be 4. Then front is equal to -1 and rear is equal to -1 because the queue is empty, because it's an empty queue. Now if I want to do an NQ operation, that is I want to push in 67, then what you have to do? The first thing you have to do is check for the overflow condition. How do I check? That is whether there is any place left in the queue or not for the insertion operation. How do I check for queue full or overflow condition? If rear is n minus 1, that is if it is pointing to the last element of the queue. So rear, normally always the insertion happens from rear, right? Rear insertion happens. So when I say rear is equal to n minus 1, you would have already reached the last element. So you wouldn't have any place left. So if rear is n minus 1, compare if rear is n minus 1. So what is n here? Rear here? -1 and 4. Okay, n minus 1 is 4 and rear is -1. They are not equal. So it will come to the next one. After that, that is you're checking for the overflow condition. If the overflow condition is not true, check if first element or not. You have to check whether the element which you are entering into the queue is the first element or not, because if it is the first element, you not only has to reset the value of rear but also the front, because front has to point to the front element or the first element. Then if you are going on deleting, then you will increment front, otherwise front will remain as it is. If front is -1, front would be -1 when there are no elements in the queue. So what you have to do? You have to reset the pointer values, that is front and rear is equal to 0. Why 0? Because q of 0 would be the first element. That is why normally it will hold the location. 0 is the location of the element. So I will say front is equal to 0 and rear is equal to 0. And then q of rear, that is nothing but q of 0. Wait, let me write that also. Q of 0 is equal to, because q of rear is, what is rear? 0, 67. So now I have rear pointing to q of 0 and front also pointing to q of 0 at present. So hopefully you have understood this step. Now let me perform one more insert operation. So now I have front and rear pointing to q of 0 and I have inserted the value 67 in that. Now I want to insert one more value here. How do I do that? NQ, for example, 88. I want to insert 88 into the list. How do I do that? First, I have to check for the overflow condition. Yes, whether there are any place in the queue or not. Check for queue overflow. How do I do that? So, rear is equal to n minus 1. Sorry, check for the rear is equal to n minus 1. So if the rear is equal to n minus 1 means there are no other places in the queue. So check whether rear is equal to n minus 1. What is rear here? The value of rear is 0 and 4. Not equal. Right? The next step is to check whether the element is the first element. How do I do that? If front is equal to -1. What is the value of front? 0 and -1, not equal. So after that, if it is not the first element and the queue is not full, what are you doing? Increment the value of rear and insert in that location. Rear plus plus, and Q of rare is equal to 88. Let us see here. Q of rare is equal to 88. Yes, rare plus plus will make you front remains there only, but rare will get incremented. So rare would be pointing to this location. Yeah, front remains there only, and then Q of rare, that is nothing but Q of rare plus plus is nothing but 0 plus 1, which is equal to 1. Q of rare is nothing but Q of 1 is equal to 88. So Q of 1 is equal to 88. So front is pointing to Q of 0th location and Q is pointing to Q of 1 location. 88 is pointing to Q of 1 location. Please have a look. Sorry, it's like confusing. Okay, see, I have rare pointing to the location 1 which has 88 stored there. That is, first it was -1, then we inserted 67. That time first we checked for overflow condition. Since rare was not equal to n minus 1, we checked whether it is the first element or not. So since front was -1, front will be -1 when the queue is empty. Only in that condition you will have front -1, otherwise you will not have front -1. So front is equal to -1. We made rare and front both of the element pointers to point to the first element, that is the element at the 0th location, that is 67. After that, again I tried to insert one more element, that is 88, into the queue. So we checked for the overflow condition. Since rare was not equal to n minus 1, it was 0, right? Because it was pointing here. Then since it was 0 and it was not which was not equal to n minus 1, then I checked whether it is the first element or not. Since front was equal to 0, it was not equal to -1 because one element is there, it's not empty, that is why it is not the first element. Then increment rare, because if you insert in this location only, it will rewrite in that place. So increment rare pointed to a blank location. So rare plus plus. So when I am inserting, since the pointer which keeps track of insertion is rare, I am incrementing rare. Front is a pointer which keeps track of the element to be deleted, and rare is the element which is inserted. So rare is incremented by 1, so it is 0 plus 1 which moves to the next location, that is Q of 1 location, and then I inserted Q of rare is nothing but Q of 1 is equal to 88. Hopefully you have understood this. Now I'll show you this insertion till it is full, the queue is full. Okay. The next one I finished. So what is the rare value here? The rare value is 1, and then the element inserted is 88. So now let me do NQ of -7. I want to insert an element -7 here. So what will I do? First thing is check for Q overflow. Or Q full. How do I check it? Check if rare is equal to n minus 1. So what is rare? Rare is 1 here. You can see it as 1, 1, and what is n minus 1? It is 4 because n is 4, not. So still I have place in my queue. What I have to do? Check 1 is not equal. So there is still I have place in my queue. Check for the queue. Sorry, what happened here? Overflow or queue full, it is not equal, right? So there is still place in my queue. Now I have to check whether this is the first element inserted. Check if it is the first element inserted to be in. How do I check it? If is equal to minus 1. So what is the value of front? 0, right? 0 and minus 1 not equal. So it is not the first element. Increment rare, right? Which is rare is equal to, what is the value of rare? What the value of rare is? 1 plus 1, which is equal to 2. So insert in the location q of rare, which is equal to q of 2, which is what value I am going to insert? I think I wanted to insert minus 7. So I will say here minus 7. Okay. So what will happen here? I said rare is equal to, rare is pointing here, rare is equal to rare plus 1. See, front is pointing at the 0th location only, because whenever rare is incremented, front doesn't get incremented unless if I delete an element now. So I will delete and increment front, so that the next element to be deleted in the queue is 88. So if I delete 67, the next element should be 88 only to be deleted. That time delete and increment. So here increment and insert, because it is pointing here, I cannot rewrite. Now I will point it to the location q of 2 and then I inserted minus 7 over there, right? Hopefully you have understood. Now the location of front is 0. Since I have not deleted any element, and the location of rare is 2, because I have inserted 3 elements. You can see rare points. So next element should be in the rare of this thing. It will go to q of 3, but the front is responsible for deletion. So the first element to be deleted should be the first element which entered the queue. So 67 was the first element which entered the queue. So front I will delete if I have to, otherwise it will be there only. Whereas rare is for insertion. So every time you insert a new element, you check whether there is place or not, or it is the first element or not, and then go on incrementing front first and then insert. So front is pointing to the latest element which is inserted, right? Now we'll do one more insertion. Hopefully you have understood this, because if you understand this, it is very easy to write the algorithm. So I will say EN NQ. I want to insert now 0. Let it be 0 to be inserted. I want to insert an element 0 at the location I will be inserting 0 at the location okay. First you have to check for Q full, check for overflow or Q full condition. How do you check? Check if rare is equal to n minus 1. What is the value of rare here? Value of rare was 2, right? So 2 and 4 not equal. So it is not overflow. Next, check if it is the first element to be inserted. So how do you check? If is equal to minus 1. So what is friend? 0 and minus 1. They are not equal. So increment rare, which is, what was the value of rare? 2. 2 plus 1, which is equal to 3, and Q of rare is equal to, what is that? Q of 3, sorry, it is not 8, it is 3, is equal to what I wanted to insert here. I wanted to insert 0, right? So I will say this is equal to 0. See, this is not an algorithm, so don't check for the syntax or algorithm errors. The only thing is I'm showing you how exactly it works, like what are the things you need to do. First overflow and then the first element, and then both of them are not true, that is the place is there, but and this is not the first element, you just increment rare and do it. If there is no place, you will print that Q overflow. If this is the first element, you have to reset both front and rare to 0 and then insert. But if it is neither of the two, then only you will increment rare and then insert in that location. This is the procedure how it works. Okay. So next is, I'll just go there on the top. I have inserted it. Okay, rare is pointing here because rare, the last element inserted was this. Now I will make it point rare plus plus. So it should point here, Q of 3 location, and then I inserted 0 there, correct? So still I haven't deleted anything, so front will be pointing there only, because whenever you plan to delete, 67 which entered the queue first should be the element which has to be deleted first. The element which entered last would be the last element going out of the queue, that is last in last out or first in first out. Now we have seen, still I have one more. Then again after that, if I try to insert, I should get an error message. So let me see, we'll also let me insert mm, 55. I want to insert 55. So how will I do that? Same procedure. Check for overflow. So how do I check? If rare is equal to n minus 1. So what is rare here? 3 and 4. So they are not equal, right? 3 is not equal to 4. So that it means that still I do have. So not. Then check. If this is the first element. How will you check? Check if is equal to minus 1. So what was the value of friend? 0 and minus 1 not equal. So rare plus plus rare is equal to 3, right, plus 1, which is equal to 4. So Q of, don't write only rare. 4 is equal to something you cannot do. Q of rare is nothing but Q of 4. In that location, I can have a value is equal to, what do I want to insert? I wanted to insert something 55, right? So I wanted to insert 55. I will insert it. We'll go up. So rare is pointing here. Now what did I do? I made rare point to this location, right? Now rare is pointing here and I inserted 55 here. So you can see all the elements, when the queue is full, then rare is pointing to n minus 1 and I have not deleted any element from the queue. So front is 0 only, rare is n minus 1. If I have to insert one more, there is no place. As you can see, there is no place. Let me see, like if I try to insert one more, what happens? Okay. Let me insert 44. Okay. Check for overflow. So check, what is that? If rare is equal to n minus 1. What is the value of rare? 4 and 4 equal. So print cannot insert element. Okay. So this is the end of it. Getting it? Hopefully you've understood the procedure, because if you understand the procedure, then you will understand the algorithm very easily. So this is Q when I have inserted all the elements and then I can see here 67, 88, minus 7, 0 and 55 are the elements in the queue, and there are totally 5 elements. So 0 to n minus 1 it is stored. Have a look. Now we'll start with the algorithm. Please make a note of the statement of that. So queue, front, rear and item, these are the terminologies I'll be using in my algorithm. Let Q be a queue consisting of n elements. The number of elements in the queue is n. Front and rear are the positions of the front and rear elements of a queue. So, front points to the element which has to be, if you perform a delete operation, the element which will get deleted, front would be pointing to that. Always it need not be the element present in the 0th location. For example, in the last example only I had around 5 elements in my queue. If I delete the first element, that is the element present at the location 0. So what will happen? It will just move out. Then front should move to the next element which would move out. That is the element at the location 1, right? That is how the queue moves. So front would be pointing to the element. If I delete from the queue, which element should go out? It would be pointing to that element, and rear would be pointing to the element which was inserted in the queue in the last. That is the latest element which was inserted, rear would be pointing to that. So rear and front, or front and rear, are the positions of the front and rear elements of the queue. This algorithm inserts an item. Item is the element which you are going to insert into the queue at the rear end of the queue, because insertion happens from rear and deletion happens from front. So, shall we start with the algorithm? The step 1, please make a note of the statement. Don't forget. Step 1, what should I do? Step 1, first I should check for the overflow condition. That is what I did, right? Because if there is place, first I have to check whether there is any place or not. Check for overflow. How do I check that? If rear is equal to n minus 1. Yes, if it is equal to n minus 1, it means that the queue is full, right? So I have to say print. What will I print? Queue is full. Queue is full. Queue is full. Overflow. After that, what I should do? Exit. Yes. After that, end if. My if ends here. This is step 1. I have to check for overflow. That is, if rear is equal to n minus 1, then print queue is full. Overflow. I don't have any place in my queue to insert. If that is not true, step 2, what will I be doing? Reposition the front and the rear pointers, because when will I do that reposition? When I check this is the first element which you are entering, like which you are inserting or not. If it is a first element, then I should make the front also point to that. Rear, anyway I'll say rear plus plus, it will automatically minus 1 plus 1 would give you 0. But then front would remain minus 1 only, which is not true. When elements are there in the queue, insertion is happened, then deletion should happen, otherwise it is not possible, right? If the queue should move on, that is the queue should, there should be some movement in the queue. For that reason I need to check whether this is the first element or not, and if it is the first element I need to reposition the front and the rear pointers. Okay, how do I do that? I have to check if front is equal to minus 1. If front is equal to minus 1, then how will I do that? I have to first say front is equal to 0, rear is equal to 0. Why is it 0? Because the location of the first element or the position of the first element is 0. After that, what will I do? If this is not true, that is, it is not the first element, then how will I do that? I have to increment rear. Okay, so I will say if this is not true, then I will say rear is equal to rear plus 1. Yeah, that is increment rear pointer. Why am I incrementing? Because it should point to a vacant location, otherwise you will be rewriting it on that only, right? So for that reason I am going to increment rear pointer. And if my if ends here, after that the next step, what should I be doing in the next step? I have to insert that one, right? So it is Q of item is equal to, sorry, Q of not item, it is Q of rear is equal to item. Okay, the next step is return. See here, what did I do? This algorithm, this ends my algorithm. So first what did I do? I checked for the overflow condition. If rear is equal to n minus 1, the queue is full, so overflow. Otherwise, you have to check this is the first element to be inserted or not. If it is the first element, you have to reposition the front and the rear pointers, because to begin with it will have minus 1 value. Both front and rear will either point to null or it will have a minus 1 value, because there are no elements in the queue. When there are no elements, it will have a negative value, minus 1 value, because the first subscript value would be 0 once you enter the elements. So if front is equal to minus 1, front would be minus 1 only when the, now for an empty queue. If there are elements, at least one element in the queue, front will not be minus 1. So then what I will do? I will make, suppose if this is the first element, I should make both front and rear point to the 0th location. right? And then only I can insert. So I am making it there. Or if it is not true, that is there is place in my queue but it is not the first element, then rare is equal to rare plus 1. So what you will do is you will increment the rare pointer by 1 because it would be pointing to a location which has some value, because it would be pointing to a location which has an item which was inserted in the end or the latest inserted item, right? So then I will say rare is equal to rare plus 1, and then after that q of rare, whether it can have, if it is a first element, rare will have 0. So q of 0 you will point to that item, or you increment rare and it will be n minus 1. So you will give q of that in that location, in the, you will increment the item and return. Getting it? Hopefully, you have understood today's class. No homework for today. Tomorrow's class will write the program as well as I will execute it and show it to you. Yeah. Stay safe. Take care. See you tomorrow. Bye bye.